Hello, everyone, and welcome to another episode of Eyes on Earth. We're a podcast that focuses on our ever-changing planet and on the people at Eros and across the globe who use remote sensing to monitor and study the health of Earth. I'm your host for this episode, John Holt. Landsat 9 is set to launch from Vandenberg Space Force Base. If all goes according to plan, the satellite will emerge from the nose cone of an Atlas V rocket and eventually join Landsat 8 to continue a nearly 50-year legacy of unbroken Earth observations. Landsat is a joint program of NASA and the U.S. Geological Survey. NASA is responsible for building and launching each satellite, after which control of the satellite is handed off to the U.S. Geological Survey. The USGS is responsible for building the ground system that collects the data as the satellites fly overhead. It's also responsible for archiving and distributing the data around the world and for maintaining data quality. So on today's episode, we're going to talk about what it takes to build a ground system and the extensive testing that takes place before and during commissioning. That's the multi-month period during which a new satellite is prepared for day-to-day operations. Joining us to talk about that is Carrie Wolf, a contractor with the Aerospace Corporation who serves as the L9 Mission Integration Lead and Ground System Manager at Eros. We also have Mike O'Brien, who's a contractor who serves as a ground station engineer at Eros. Carrie and Michael, welcome to Eyes on Earth.
Thank you.
Thank you, John.
Carrie, let's start with you. First off, let's talk about what a ground system is. What makes up a ground system? I mean, are we talking about receiving stations, computer software? What does it take to get Landsat data out of the sky and into the hands of the public?
Well, we're really talking about all of the above. So the ground system, in simple terms, is everything on the ground that's needed to command the satellite, receive image data, and turn that data into science products that are then distributed to the public. The ground system has three major components. The Landsat Multi-Satellite Operations Center, or the LMOC, at NASA Goddard in Greenbelt, Maryland, and it provides command and control capabilities for the mission. It also includes Landsat ground networks, which is how we command the satellite from the LMOC and receive image data back to the ground. The L9 critical satellite ground stations are located really all over the globe. Here in Sioux Falls, South Dakota, there's a station in Svalbard, Norway. We have one in Fairbanks, Alaska, Alice Springs, Australia, and Neustrelitz, Germany. So they really provide good coverage across the globe. These ground networks route all the science data back to Eros for data processing, which is really the third critical piece of the ground system, the data processing and archive system, which takes data from the satellite, processes it into science products, and then distributes it widely to the user community.
You use the term science products several times. When you say that, you're talking about, I guess, what the general public would see as satellite imagery. We see it as satellite imagery. When we share it, we think of it as satellite imagery, but you're really talking about processing the data into that imagery and products beyond that, like next level Landsat products. Is that right?
That's correct, right. Yes, the data that comes directly off of the observatory in its raw form wouldn't be very useful. We do have to do some second level processing to turn that into these pretty products that the science community and all the user community is used to seeing.
And I want to stay on that point for just a second because you talk about the data that's coming down. It's not just image data, right? Like you get a lot of information from these birds, even down to the temperature of the components of the instrument. Can you talk a little bit about that, like all the stuff that you get that has to be processed by the ground system?
We receive all sorts of telemetry about the satellite itself. We're very interested in the science data and in the imagery that is picked up or that we get from the instruments. But of course, we have all sorts of ancillary data. And we need to understand where the satellite is when the imagery is taken. We monitor all sorts of data from the observatory, just like you said, temperature. There's all sorts of limits and controls that are being monitored continuously by our flight operations team. And all of that data gets sent back to the engineers and analysts. There's kind of multiple things always going on at the same time.
There's a lot of knowledge packed into those Landsat scenes that we see. There's a lot of processing and a lot of information that you got before we got those.
Absolutely, right. We need to have additional information about each scene so that we can accurately process that and account for radiometric and geometric differences and correct for those in order to make the quality products that we have.
It sounds like a pretty complicated process, a little more complicated perhaps than just shooting a snapshot and handing it off to your friend or texting it to your friend. Mike, let's turn to you for a second. Tell us about Landsat's ground stations, because I know you've been to at least a few of these. What kind of testing took place to prepare those stations for Landsat 9?
That's a good question, and I have been to all 5 of our LGN stations.
Oh, wow. So you filled out your whole scavenger hunt, like lottery card. Okay,
that's correct. Yep. We call our connection of ground stations the Landsat Ground Network, LGN for short, and that includes the 5 stations that Carrie had mentioned. Testing that goes on for these missions, we have to essentially build the ground station while the spacecraft's being built and try to make the tests meaningful so we can ensure that the ground stations will be able to receive the data from the as-built spacecraft. There's many ways we do this. The testing is extensive and significant, and generally I'll go to the station and we'll do all of our development and integration. Then we start testing, and we'll do that in several phases. And a lot of this is just due to the fact that it takes 2 to 3 years to build a spacecraft, and things can change ever so slightly during a spacecraft build. So we have to modify our testing as time goes on. Luckily, in the Landsat 9 situation here, we have a spacecraft that's being built that's nearly identical to the Landsat 8 spacecraft. So we can take a lot of the testing that we did for Landsat 8 and even take Landsat 8's mission itself and use that, showing that the ground station can in fact receive that frequency, that data rate, that modulation type, etc., which gives us a lot more confidence on the ground that we'll be able to receive the data without any issues. Obviously, every ground station is different. The equipment that composes the ground station is radically different from one to the other. So we have to kind of make the tests somewhat generic from the outside and then tailor them specific to the equipment for the actual ground station.
Well, that's really interesting. So you're saying that you can't just build one ground system, one set of software, and sort of ship it around the globe. It has to be tailored to each of these stations.
That's correct. All of these ground stations that we mentioned are living entities. They have other missions going on. Their equipment's working and being repaired, et cetera, et cetera. So it's a living ground station. Landsat is just one mission. The Svalbard ground station, due to its proximity on the Earth, it can take more passes during a day. When we started working with Svalbard in Landsat 7, we installed their first antenna. Now they have 189 antennas, and they take roughly 60,000 passes a month across hundreds of missions. Fairbanks also in a similar situation. They take several thousand passes a month, 4,800 right now, across their 3 antennas that we share with the Landsat project. And then here in Sioux Falls, obviously, we're dedicated to the Landsat mission. So we do Landsat 7, 8, and upcoming 9. But we have done tons of other missions as proof of concept in helping support our fellow partners across the globe trying to do things for science.
That reminds me of another topic that we want to cover in relation to Landsat 9, and that is the Landsat Multi-Satellite Operations Center, the LMOC, and ARO's status with Landsat 9 as a backup LMOC.
The LMOC performs a lot of critical functions for the mission. They perform things like command and control of the satellite, mission acquisition, planning and scheduling, flight dynamics. They do data management, analysis of the data, and much more. During launch and early orbit, the LMOC is a very busy place. We have a consolidated flight operations team that is performing Landsat 8 and Landsat 9 operations out of this multi-satellite MOC. They're very busy come launch time. Not only is the LMOC and the launch support room full of flight operations team members, but there's lots of engineers supporting the activities at that time. USGS has a large team of subject matter experts, and they provide 24/7 support during launch, analyzing data and ensuring everything is functional. The backup MOC, which is located at AROS, as you mentioned, is not yet functional, but it has gone through quite a bit of testing already, and we're planning for that to be functional or operational shortly after handover of the mission from NASA to USGS. It'll serve as the backup to the primary LMOC. That can actually be used in a few different ways, and there's various levels of failures that can occur. If we have a pretty local failure of networks or a facility type of failure, they can reach the BLMOC at AROS remotely from a separate location. However, if there was something larger scale, some catastrophic failure at NASA that didn't allow them remote access, they could fly to AROS and sit console in the BLMOC and operate the mission from there as well.
Let's talk about how the USGS sees the data from this observatory before the launch. We built a hallway ground system in Arizona while Landsat 9 was being built and tested. What is that? What is a hallway ground system, and how does it help the USGS prepare to do its job after launch?
Years ago, NASA had something called a compatibility test van that we would take all over the world, and you would plug it into the ground station and play a spacecraft simulated data to ensure the ground station could receive the data. So it was a big semi-trailer full of all kinds of different equipment, and we take it all over the world. Right before Landsat 7 launched, the compatibility test van itself was decommissioned. One of the inherent problems there is, as I mentioned, we have different equipment at all the ground stations. Ground stations buy their own equipment. They have their own stuff, antennas, receivers, basically everything. So we took representative equipment from all the different stations that we worked with. For Landsat 8, it was just the 3, Sioux Falls, Fairbanks, and Svalbard, Norway. And we built a miniature ground station minus the antenna kind of in the hallway right outside where the spacecraft is built. And how a spacecraft is built is, you start out with the very first piece, and then you start adding pieces to the spacecraft. And each time a piece is added, you essentially run a big, long test. That way, after you get 50 pieces on the spacecraft, you can tell where things started to change or something went wrong, etc. Anyway, so we set the equipment up, and as soon as we're able, we start allowing the signals to get to our hallway ground station. In Landsat 8, because this was new, we started finding problems with the spacecraft during the build, problems that weren't obvious. They would have been found. The previous iteration of the testing before the hallway ground station is collect a bunch of data doing their test, and then they would ship it off, say, to Eros, and then we would process it and then find bad things and then report back. So it'd be weeks before you actually responded to a problem. Now we have a representative ground station in the hall that can detect these errors and problems right away. And then we can give immediate feedback to our partners in NASA and the spacecraft vendor itself so we can work out these issues as they go. We did it on Landsat 9 and made it better. We made it slightly smaller, more compact. We kept a core set of ground station equipment attached to the spacecraft. When they turned on one of the instruments, we could monitor the data that comes from it, and then we turn on the other instrument, and then we could see what happens to the spacecraft when both instruments are sending data at the same time.
And again, the instruments we're talking about, the actual data collection, the operational land imager 2 and thermal infrared sensor 2 for
Landsat. That's what we know it as, OLI and TIRS.
Right.
When those start operating, those are the ones that actually take the pretty pictures that we see in the hallway, and we can monitor that as it's happening. We can see it, and that mimics what happens on orbit. I think everybody, even the instrument teams and the spacecraft vendor itself, Northrop Grumman, and our NASA partners all loved and appreciated the HGS as time went on, because we were able to show things. There's a problem here, and then we were able to fix it and move on, and it just made everybody happy. I think it'll be something that continues not only for us. I've received several communications from other missions about doing similar setups for other missions that aren't Landsat related.
This is not actual, satellite collected data. This is sort of dummy data, so to speak, but it's in the format that you're going to see from the satellite. And you have each of the ground stations that will collect the data represented, like here's Svalbard. Do they have labels or anything? I mean, now we're in Svalbard and you take 2 steps and you're over in Fairbanks. I mean, does it work that way?
It kind of does. We have them all in racks, and then all the stations have call signs. Like our call sign in Sioux Falls is LGS, Landsat Ground Station. We use SGS, Svalbard Ground Station for Svalbard, and GLC for Gilmore Creek, which is Fairbanks Station. The little town that it's in is actually Gilmore Creek. So when we capture the data, we actually capture it, and it comes out, and the processing system would know that this was a Svalbard capture.
We learned a lot from the development of the hallway ground system that we did on Landsat 8. As Mike was saying, we kind of built that out of necessity. It was a great idea by a group of engineers that said, hey, what if we did this? It might be a great way to capture data and get a look at the data and test some things out. And it was so valuable that on Landsat 9, we took what we had learned and then deliberately built another one. It really has been an invaluable tool, and it's been even more broadly used than originally anticipating on Landsat 9. So we keep learning new ways to leverage this great asset that we had sitting near the observatory throughout the testing phase.
Right. And again, this is the USGS part of the show. This is what we do. And we were doing this as the satellite was being built. USGS is not sort of sitting on our hands and waiting. This is something that's been going on the whole time.
That's right. Yeah. So within the ground system, this was a big piece of preparation. And in the meantime, the development for all the functionality within the LMOC was being built and delivered and installed in the operations center at Goddard. And simultaneously, the data processing system was also being built. They all kind of worked together. And Mike talked about the testing that was done at the station. So all of this work was happening at the same time that the instruments and the spacecraft were all being built and integrated and tested. All this work's going on simultaneously. So it really has been a very good representation of a joint agency mission from the very beginning. Everyone's been very busy. Right. We're very excited to see it all come together at launch.
You've been very busy. You've done a lot of testing. So surely, Carrie, after launch, it's just a matter of flipping the switch and pumping the data out into the world, right? Or maybe
not exactly. There is a lot that goes into making the science products that go out to the public. This isn't something that a lot of people see, but there's a lot of work that happens behind the scenes. There's a team of, I'll call them world-class software developers at AROS that takes the data from the observatory and they apply several layers of data processing using complicated algorithms to create the products. Radiometric, geometric corrections, terrain and atmospheric corrections. It allows them to produce the various levels of high quality science images that are made available to the public. Landsat data is processed so accurately that it really is considered the gold standard in the industry for data quality. So many scientists and other, academia, they leverage this data as their benchmark when they're doing studies, when they're doing research. We really put a lot of emphasis on making sure that the data is highest quality. This highly skilled team, they develop all the software and they continue to correct for changes throughout the mission as it's being operated for years to come.
This is not something that you just start doing immediately after launch. This is something that you work through during the commissioning phase, right? The 100 days or so after launch. There's a lot of activity taking place. Can you talk a little bit about that?
Once we launch, of course, the spacecraft and the instruments will go through a series of checkouts to ensure everything's functioning. But once image data actually starts to flow is really the first time that we get to truly test this system that's been developed over the last several years. And this team will take a look at the data and what they've developed and understand that it's going to require, some tweaks and some correcting. And that's the case with every mission. The true test is when you actually receive that on-orbit data. And a lot of this does happen throughout the commissioning phase, that roughly 3-month period. We'll begin to start that process, but we really won't have it perfected for some time into the future. The current plan is that products will be available roughly at the end of the commissioning period, which is scheduled for the January timeframe.
And in the in-between period is when all this work that you're talking about is going to take place. A lot of the calibration and the radiometric corrections to make sure that what we see is as accurate as possible, a reflection of what is on the ground. Landsat 8 and Landsat 9 will be flying sort of together as part of that process to help you get ready for this. Can you talk to us at all about some of that?
Yes, we are planning to do an underfly. We want to help with the processing of Landsat 9 data using what we already know from Landsat 8. This helps us to calibrate and validate the data that we're seeing and helps us to produce a better quality product for Landsat 9.
So essentially, Landsat 8 and Landsat 9, during this commissioning phase, Landsat 8 will be collecting actual data that will be processed and turned into products that any of us can go download. And at the same time, Landsat 9 will be under there collecting data for those same points on the ground, and you'll sort of use that to make sure that Landsat 9 is ready and to calibrate and everything. Is that right?
That's correct. Mm-hmm.
Okay. We've reached the point in the show when I want to ask you about your closing thoughts. I think, Mike, we'll turn to you because we were just talking to Carrie. Mike, what's on your mind a few weeks out from the L9 launch?
Well, obviously, I'm excited. It's been a long road, and I'm ready for a couple of weeks off. For the launch, we usually get spread out. I personally will be in Fairbanks, Alaska for this launch. I was for Landsat 8 as well, and that's due to the first couple of orbits after separation. We see the spacecraft many more times at Fairbanks and Svalbard. I'm excited. I'm ready. and I need a nap.
Carrie, what about you? What's on your mind today?
Well, as Mike said, it's always very exciting. The Landsat program doesn't launch a new satellite very often. And so everyone's excited, from the engineers and the developers and everyone who worked on this mission for the last 6 or so years, to see it all come together. I mean, it really is about the science in the end. There's a lot that goes into it, and it's really all about seeing the products come out. It's also a little scary, of course. But everyone, I think, is mostly excited and ready to see the data come down, ready to see the fruits of their labor and all the testing that took place. So we're very excited. We're hoping that everything looks as it should once it's on orbit, and we're really confident going into launch. So we're hoping for the best.
That's a really interesting point, that the number that you threw out there is like sort of a 6-year process, because I think in the minds of the public, at least what we would see, if you're sort of a casual observer, you're going to hear that maybe Landsat 9 is going to launch. Maybe you'll see it, you'll watch NASA TV, and then a few months later, Landsat 9 imagery might show up in your social media feed or something along those lines. But really, this has been going for several years. All of this work that we're talking about goes into that launch. And then after the launch, you have so much work to do to get ready. This is really an intensive process and a big moment for the USGS and NASA, isn't it?
Oh, absolutely. There's so many people who've been waiting for this moment. And anytime you have a launch like this, you've got extra staff on hand because there's so many new data points to monitor all at once. If you were to walk into the Mission Operations Center or into the launch support room around launch or a few days after, it would just look like a flurry of activity. It really is. There's a lot that goes into it. Everyone's monitoring the data. Everyone's looking at the output. The first couple of weeks especially are very anxious. But as we start to get through the checkouts on orbit of all the instrument components and all the spacecraft components and start to see data flow, everyone breathes a big sigh of relief. So that's always a good feeling.
We've been talking with Carrie Wolf and Mike O'Brien about the preparations for Landsat 9 and the Landsat 9 ground system. And Landsat 9 is set to launch this month to continue the Landsat legacy. Thank you so much for joining us, Carrie.
Thanks for having me.
And thank you, Mike.
Thanks for having me as well.
And thank you to the listeners as well. You can find every episode of Eyes on Earth on our website. That's usgs.gov/EROS. That's usgs.gov/EROS. Be sure to follow our Facebook and Twitter pages for the latest episodes. And check us out on Apple Podcasts or Google Podcasts. This podcast is a product of the U.S. Geological Survey, Department of Interior.